Hi, everybody. Thank you for that lovely introduction and for having me here. My name's Anya. Like we said, I run a product group at Bloomberg for AI platforms in our CTO office, where we focus on AI infrastructure, developer tooling, systems that power AI applications across Bloomberg. I also happen to be a governing member of the Agentic AI Foundation, the AAIF, a neutral open source foundation, part of the Linux Foundation umbrella, that ensures that these types of capabilities evolve transparently, collaboratively, in ways that advance the adoption of leading open source technology and AI projects, including MCP, or Model Context Protocol, which I'll touch on a bit today. So audience participation time. Who here has seen one of these lovely Bloomberg terminals before? Oh, great. Very good. Contrary to what you may have read on the internet, I don't think it's actually that easy to vibe code in a weekend. Ooh. But with the remaining 13 minutes, I hope to tell you a little bit as to why I think that's the case. And while interoperability really helps us connect our systems, trustworthy infrastructure is what makes them truly viable in production and for our clients. Okay. Context. So why do we care? Why are we here? Well, for more than 40 years now, leaders in the global financial markets have trusted Bloomberg to serve up all kinds of valuable information, like you see on the left-hand side, that they need to make critical financial decisions. And these types of customers that we care about include folks on the buy side, like wealth asset managers, portfolio managers, hedge funds, pension funds, wealth managers who can help advise clients on investments and their portfolios and opportunities. It includes sell-side clients like traders or research analysts, brokers, market makers, and investment banks. It includes corporations or those who can facilitate transactions between buyers and sellers. The common thread is that financial decisions are made in high-stakes, very regulated environments, highly regulated environments. And across all these participants means that across the industry, there are significant expectations across transparency and accuracy and market integrity. Okay, so we're at a Frontiers of AI Summit. So how does AI fit in? Well, there we go. Bloomberg was founded in 1981. I see one of our founders in the audience, with the goal of bringing transparency to finance through cutting-edge technology. And since around 2009, AI has really been part of our continuous innovation to support that goal. So it's been incorporated into multiple Bloomberg products and has been iterated on over time. So for example, animations, technology introduced in 2012 to enhance the search functionality on the terminal evolved into the natural language search functionality that we see that's driven by AI and NLP today. And so while generative AI may seem quite new, we've been applying different forms of AI for more than 15 years, which actually has brought us to where we are now. So AI continues to enhance many of Bloomberg Terminal's very popular functions. At the same time, our global team of AI researchers and engineers, some of which are in the audience, are developing new tools to drive responsible AI forward and reimagining what we can actually provide our clients. Okay, so that brings us to 2026. So back in January, we've officially announced Ask B, our flagship agentic AI experience on the terminal, which fundamentally shifts how our customers might discover insights from interacting with them through a conversational interface. And this builds on years of those AI-powered features such as search and summarization and those experience layers that I mentioned on the previous slide. This experience has really shaped how we think about trustworthy AI products. So for us, this means, three guiding principles. We have to derive answers from trusted sources of information. We have to provide transparent attribution for our clients so they can actually go and verify this for themselves, the answers for themselves. And most importantly, we have to build features that solve actual usable problems. None of this is possible without the right AI infrastructure and platforms underneath. So underneath this big network, there are gateways, there are models, there are tools, there are agents. There's a lot of domain expertise that gets imbued into there to do the right thing. And from an infrastructure perspective, yes, we need our nines. That's just table stakes. But to uphold our product principles, we have to apply controls at runtime so you can guide system behavior and enforce policies or standards, but at the same time, complement it with a way to have continuous development and improvement on the product as the technology rapidly evolves. So to play this out, we need a couple pieces: an interoperability story to develop really quickly, as well as standards for context control and for verification. Okay, so that's where MCP comes in. Model Context Protocol is often described as the USB-C cable for AI systems. I'm sure you have them running on your laptops right now. But USB-C didn't eliminate the hardware complexity, it just standardized how devices can connect. So MCP does something very similar for agents and for tools. It gives us a common interface that we can use for exposing capabilities to AI systems. The agents are effectively the ports, the tools are the devices that are plugging in, and we can connect the capabilities dynamically as opposed to building bespoke integrations. So this protocol defines how capabilities also can describe themselves, what they can do, what inputs they expect, what constraints exist, and how they should be invoked, which is very useful when you have an agent as a user. This standardization has been incredible for product development. The same way I can just plug in a drum sampler or a vocoder into my laptop without like hardwiring custom audio infrastructure together. I don't have to rebuild integrations all from scratch every time. Teams can compose AI systems very richly, much more quickly with shared infrastructure, shared interfaces, and it's very reusable. So AskB is powered in some part by MCP as we use it for agentic interoperability. So it looks something like this. When a user comes in and they ask a question on the terminal, AskB understands the full context. It might look at market events. It might understand the user's intent using those AI-enabled applications. And with that context, it can dynamically orchestrate MCP tool calls, server calls, by calling the right capabilities at the right time to retrieve data, to run analysis, or potentially even take actions if so called. This creates our continuous agentic loop, refining and enriching and validating results. So the result is a much more context-rich response report that's delivered back to the user. So inside this workflow, there are many different trust boundaries that are being crossed. On the left side, we have a client trusted environment, the Bloomberg terminal session, authenticated user context. On the right side, we now have a growing ecosystem of tools being developed rapidly by our department, models, runtimes, potentially external systems, APIs that are being enabled through these MCP-powered workflows. So increasingly, these AI systems are not just retrieving information from environments, but maybe taking actions across them. And this means the agent is effectively operating across trust boundaries. Data or instructions that are considered safe on one side of the boundary may actually need to be treated as potentially untrusted on the other side. So how do we enable AI to act across all these systems while still maintaining that level of trust and control and transparency that financial markets really demand? Well, we've been working with the open source community, specifically through the AEIF and the Model Context Protocol Financial Services Interest Group, which is focusing on advancing a protocol for uses in financial services environments or regulated environments in spaces like compliance, auditability, data lineage, provenance, guardrails, and attestation. Okay, so two concepts that I'd like to highlight from that space are interceptors and for variants. I've talked a lot about trustworthiness, which is a core tenet of responsible AI. We can think about this through a very simple lens, and I thank Sebastian for this diagram who's sitting in the front audience. AI systems should be both helpful to our users and harmless to markets and clients. What does harmful actually look like in this case? Well, unlike general consumer AI, basic check applications, mistakes in financial AI systems can create real legal, market, and reputational risk. This includes things like confidential disclosure of sensitive or non-public information, unauthorized financial advice or transactions, market manipulation, misconduct, misleading or fabricated or hallucinated financial narratives. To mitigate these risks, we've developed a finance-specific taxonomy of safeguards that kind of help guide our AI systems within this happy green quadrant. And if you'd like to know more, I definitely turn you to Sebastian, who's the head of our responsible AI. I can tell you all about it. So now the challenge becomes integrating these services consistently as the data flows across these tools and across these boundaries. And that's where something like interceptors might come in. So the interceptor framework allows us to intercept and to validate and to transform messages at different points throughout the protocol lifecycle. In other words, it allows you to invoke controls directly at the protocol layer that get deterministically executed. And there are two core types. Those of you who are fans of Kubernetes might have this sound familiar. One is a validator, which allows you to answer, is this safe? By inspecting payloads, enforcing policy if needed. And the second type is a mutator, which allows you to answer the question or say, make this safe by transforming payloads, by redacting things, by enriching, by normalizing them. So interceptors are one way that we can consistently apply certain guardrails that we like to have in place, or even uphold basic product principles like, verifying or ensuring that we have citations for every single answer. So if this is interesting to you, this is being worked on out in the open in the Specification Enhancement Protocol, or SEP 1763. And you can go ahead and read all about it and contribute. So this gives us some context governance. And then what do we do to address the variability that comes with using various models and agents and contexts? Well, that's where variants come in. So in our environment, we have many flavors of models. They could be open weight, they could be commercial, they could be homegrown, grass-fed, fine-tuned for finance. So now we have a challenge. We have to expose the same capability, but to very different types of models or agents or contexts. And these models don't necessarily interpret the tools or the MCP servers in the same way. So here's a very basic example. Get portfolio. If you're allergic to that, you can think like basic file system operations, for example, like get file systems or something. And I have 3 flavors that I laid out here. One is a coding assistant or a model family A. Maybe you have to have much more rich information for the end user. The second is a maybe token efficient automation. You're going to be spending a lot of money in that space and you want to be much more compact. And the third flavor is a conversational interface. And so naively, I can either build 3 separate MCP servers for the same business logic, or I can build one server, one generic tool that doesn't really serve any agent optimally. So this is where something where variants might come in. It allows MCP to expose multiple flavors of the same capability. Each variant can be optimized for a different model, for a different agent, for a different use case, for a different environment. And variants also allow to dynamically select the right interface for each situation given some hints. So you could say, give me the one that's more compact, or give me the one that understands XML. So what does this have to do with being trustworthy? At first glance, it seems a bit more flexible, but it actually, I think it actually makes things more predictable, more controllable, and much more evolvable. So we avoid duplication here by bundling different configurations of the same capability into a single structured unit, while enabling safe evolution. And I think without variants, you actually get much more noisy evaluation of results and much more inconsistent behavior. But with variants, each model family gets an interface that's designed for it, and you reduce the ambiguity. So if this is interesting, this work is being formalized via SEP 2053, also out there as an extension. All right, that was a bit of a whirlwind, but the core idea for me is simple. Trustworthiness really emerges from the ground up. It comes through how we design our systems. And if this is a space that interests you, if you want to build in, we'd love to have you involved. So these ideas are being shaped through the MCP project, through the Financial Services Interest Group, through the Agentic AI Foundation, and through the broader community.